Welcome everybody. Thank you all for coming. It's a wonderful day, especially after the great win we had yesterday. Go Pack. Of course, we don't have to worry about Kentucky next round, so that's good. Apparently somebody picked Kentucky to win it all, so. It's my pleasure to be here for the annual Dr. Carl Zorowski Distinguished Lecture in our department. This is the third. We started right after COVID the first year, and then last year we had one of our alumni, Eric Warren, who is at GM Racing, and many people don't know Dr. Zorowski was very big into car racing. I think his daughter was in the pit with him, helping him race. I heard many interesting stories about that. But more importantly, that was one of the reasons we had invited Eric Warren. This year we have another interesting lecture with Dr. Bridget Munro, and we'll do the introduction in a minute. But I want to thank the Zorowski family for continuing the legacy of Dr. Carl Zorowski. He was in our department for a long time. He did tell me a story about how he moved from Carnegie Mellon to here many years ago, and we found like a home here, and he really enjoyed being in the department, and ended up being our department head for many years and making a huge impact. And I still meet a lot of alumni from the 70s and 80s who talk about his impact on it. They say about students in his career, and making sure he was always very student-centric. He was very much focused on hands-on, and he also helped with the senior design, the development of the senior design in mechanical engineering, especially on the industry-funded side. It was a one-semester sequence, but I converted it into a full-year sequence to get greater benefit out of that program. But certainly he laid the seed for it, and our students are really better for it, especially because they interact with the industry sponsor all through the year. And I think we have a very unique mechanical engineering senior design thanks to his efforts for that. He was also very instrumental in starting international collaboration with China, where he and Dr. Aishan and he went several times to China taking students, especially with Caterpillar, if I remember right. Caterpillar was the sponsor for that. And of course, unfortunately, now we don't have it, especially since COVID. We have not really engaged much on that side. But he did go every year diligently. Even when I got here in 2017, he was still active in that. He was still doing that. And then about 2018 or 2019, he indicated that he wanted to start a lecture series, because at that time we had just started a lecture series in aerospace engineering, and he felt like we also should have one more lecture series in mechanical engineering, and he was very keen on that. So that's how the conversation started, and unfortunately he passed away before we could have the first lecture. And I'm glad to say that we are continuing what his intent was to create this lecture series. Just to get us started, I'm going to invite Hank Cook, who is a class of 76 from our department, had a strong association with Dr. Zorowski, to say a few words.
Thank you. Well, thank you, Dr. Akkad. It's great being here today. And I'm really looking forward to Dr. Munro's presentation. But before we get started, I just want to share a few thoughts with you on this lecture's benefactor, Carl Zorowski. Dr. Zorowski was quite an accomplished engineer. He was a teacher, a researcher, an innovator, a leader, administrator, and the list goes on. His many contributions, of which there were so many, have been recognized by Pi Tau Sigma, ASME, the North Carolina Engineering Foundation, the university's Board of Trustees, and then even after retirement, recognized by NC State's international programs and the College of Engineering. So why is Dr. Zorowski so important to me? Well, I was fortunate enough when I was here in the 70s that he was the department head of mechanical and aerospace. And he was an enthusiastic friend and motivator to all of his students. He was so approachable and so friendly. to me was an inspiration and a role model. He was all about his students, as Dr. Arquette was saying, and I'm still in awe of that summer abroad program that he started in 2007, taking students to China. Dr. Zorowski endowed this lecture shortly before he passed away, just not quite 3 years ago, but he did it for you as students, and so I hope you see the importance of that, the significance of it. It's good to see so many of you here today. I'm also glad a few others have joined us. It makes this lecture real special for me that two of my other 1976 classmates have joined me, Hayden Moore and Ed Richburg, and a good friend, classmate from 73, Randy Peacock, is here. All of us knew Dr. Zorowski and we're thankful for what he did for us and all of his students and for NC State University. Thanks so much. Dr. Arquette.
Thank you, Hank, and we certainly think there are many other ways to honor Dr. Zorowski, especially the senior design side of it, so we constantly invoke his name in our senior design annual presentation, which is in April 11th to 13th for this year. If you are here, please come by and see our industry-funded projects for this year. The students will be demonstrating, they're presenting and demonstrating their prototypes for their senior design projects. Okay, now to the main thing we are here for. Let me wear my glasses. And so it's my pleasure. I want to first thank two people who are very instrumental in bringing Dr. Bridget Munro, is Dr. Kate Saul and Dr. Jeff Eischen. Both were gung-ho about bringing Dr. Munro here, and they started the process early on, and I'm glad to say we are happy to see Dr. Munro arrive here and give us this talk. Dr. Bridget Munro leads women's research in the Nike Sports Research Laboratory. Her team focuses on how we can use science to harness human potential and create the next generation of game-changing apparel and footwear products and services, particularly focused on the female athlete. Bridget gained her PhD in applied biomechanics from University of Wollongong in Australia and pursued an academic career path before moving to Nike. Her research background, be like Mike, Nike. Her research background has spanned working to improve the performance of elite athletes through injury prevention, clinical populations to enable them to move, and working with smart materials for medical devices. At Nike, Bridget is catalyzing learning more about female athletes, particularly through the lens of inclusivity, to help them stay safe and motivated in their activity journey. Last night, Bridget was saying that there are several athletes that come regularly to her lab where she takes measurements and does research on gait and all the other stuff to develop products that are improving women's health, especially athletic performance. So, Bridget, please share with us.
Good morning. Can everyone hear me? Okay. Well, thank you, Dr. Eckert. Thank you, Dr. Saul, for the invitation, and Dr. Eischen. And welcome to you all this morning. I'm excited to see you all here. And the title of the talk is really thinking about sports science as a competitive advantage for her at Nike. First of all, I'd just really like to say how privileged I've been to be invited to give this distinguished lecture. And although I unfortunately didn't get to know Dr. Zorowski, I tried to do a little bit of reading and background on him. And I was really motivated by his approach, this hands-on approach to learning, and how much he loved his students. And in touring yesterday, I just saw all of that collegiality and that hands-on approach to learning, which was just amazing to see. What was really interesting is how many parallels Dr. Zorowski has with one of our founders, Dr. Bill Bauman, our legendary run coach. He was a coach, he was an innovator, and he also did things on the track. Maybe a different type of track. His was a running track rather than a racing track, but they were both racing to some extent. And Bill Bauman was also the person at Nike who said that if you have a body, you're an athlete. So I just want you to really think about that as I talk today, that every person who has a body, we consider an athlete. And so when I use the word athlete, I'm thinking about every single one of you. So a little bit of background about me, because I've come from another part of the world, down the other end. I'm actually from the small island, Tasmania, right down the bottom. And then I went to Wollongong University to do my undergraduate degree from an exercise science perspective, fell in love with this field of biomechanics and pursued PhD and research in that area. After graduating, I worked at the CSIRO, which is the Australian Commonwealth Science and Industry Research Organisation, then went back to University of Wollongong as faculty, and then after a while wanted a new challenge, and so moved over to the Australian Research Centre for Electromaterial Science, and so I was doing strategy and research, looking at conducting polymers and material science, and really trying to integrate my field of the athlete in different areas. As you said, I've worked on a lot of different things. I worked on injury, sorry for the picture that I've put up there, really thinking about ACL and knee injuries and trying to come up with ways that we might be able to reduce those. I've worked in prostheses, training, thinking about breast cancer patients, a lot on foot structure and foot function and health throughout the clinical age and through. My PhD was actually on designing slippers for older people to reduce falls, so a little different to maybe where I am now, so in that clinical space. And also looked at bras. I've done work in hang gliding, parachuting, underground mining, so quite an expansive sort of area, but all with this aim of how do I allow someone to be active and continue their activity in the way they want to. I then moved to Nike, and so I've been at Nike for 10 years, and I wanted to put up two pictures. When I first got to Nike, the first shoe product I worked on was the Nike Free with the auxetic midsole. Trying to really think about how the foot moves and how we can contribute further to that natural motion of the foot. And then after a bit of a journey, I then moved into apparel. And so the very first apparel project that I worked on was the fly knit bra, when we were looking at how to use flat knit as a medium to build in support in a single layer structure. So that's very different for bras. I've done a lot of projects in between, but it's nice and special to think about your first two projects. But you will also see the swoosh. So disclaimer, I work at Nike. I'm not trying to sell you anything, but I am going to try and tell you about how we use sports science as a separator to solve problems for athletes and to build projects or products and services to try and allow them to reach their potential. Because, as our executive chairman, Mark Parker, says, Nike is in the business of maximizing human potential. And I really think this is an important word to put up, this maximizing human potential. Human potential could mean I'm going for a gold medal. Human potential could mean I just want to run every day. I want to be active. So it's really trying to say, as you have a body, you're an athlete, and how do we make all of you better in the way that you want to become better? So let's talk about the Nike Sport Research Lab. The Sport Research Lab was really generated in 1980, so there's been more than 40 years of sports research. It literally started as a tin shed, and you can see the branding of the backward swoosh that made it very secret. No one knew it was a Nike Sport Research Lab. And for those of you in the biomechanics area, you can probably see over in the picture people like a Dr. Ned Frederick, a Dr. Tom Clark, some of the people who have been instrumental in sports biomechanics and footwear biomechanics in the past. So we have 40 years of research, and we have 40 years of research on multiple athlete types. Now, our lab has changed and iterated a lot. This is our brand new building. This is what we call the LeBron James building, and it's the innovation building. So the Nike Sport Research Lab sits within our innovation collective. The building has been built so that we can work at all levels. This is our new research lab, where it's about 80,000 square feet of space, where we have environmental chambers, we have full tracks, we have full basketball courts, treadmill bays, perception spaces. So you can sort of see the lab. We have multiple cameras and force platforms, lots of different tools, which makes it really fun. But the big thing about moving to this new space is really saying that as a lab, the thing that we were missing was the ability to play. So we would do a lot of fantastic work and had great lab spaces always, but we were missing this ability to really assess athletes while they were in the moment of play. And so that's what we've really tried to generate with this new space. So while someone's playing the basketball game, we can be getting full mocap, full ground reaction forces, and anything else we might want from that. And so really that means that as a lab, we are really trying to serve the global athlete holistically through the relentless pursuit of science. And global is something that is important to us, making sure that we are talking about all athletes and holistically. So head to toe, in to out. We're not just footwear, we do apparel. We're really trying to work out how we can make athletes to be their better self. In terms of who is in the lab, we have a full-time team of just over 70 people. In that we cover the fields of biomechanics, physiology, athlete performance, mind sciences, so neurosciences, perception scientists, behavioral scientists. We also do data science and we do sports science experience. So we are doing everything from servicing our elite athletes, doing research to understand and build better product, and then making sure that we can also apply some of those high fidelity things, high fidelity bits of data into a way that we can talk to many consumers. And I think it's really important that right now we talk about the art and the science coming together. I'm a scientist, I love data and numbers, it's very exciting, but without the amazing teams that do the work, that build the products, the tech devs, the designers, the storytellers, none of this comes together. And so I want to say that I'm going to talk through some examples that we've been working on recently, particularly for our female athlete. This comes from a team. This isn't just me. This is a team approach, diversity of thought, and we really get to work with all of our builders and makers to see these come to fruition to make an impact on the athlete. Okay, so I just wanted to really thank the amazing team that we have back at home, and just how exciting it is to see that sports science is growing to be that big differentiator for a company like Nike. So the first example I wanted to talk through, some of you might remember Breaking 2. And I can see you all saying, wait, she said we were going to talk about women and we've gone straight to men. But let's get there. So you may have seen the project Breaking 2. This was a project really saying that when the record in the men's marathon was around 2:02, could we try and work with athletes and product and take a holistic approach to see if we could break that milestone? And in going through that, like this was sort of happening around 2016, 2017, what really came out is, if we take a step back, could we think about the question in a different way? And we started to think about, what do we know about this topic of fatigue? And once we know about this topic of fatigue, could we actually do math? I promise not to put math up, but we might have a few algorithms, we'll say. But could we really think about this from a standpoint that allows us to break this record? And so through this journey of fatigue, we then started to think about what do we know and what do we need to learn in laboratory, in field, and where should we focus? So we focused on running. What do we know about fatigue in running? We then started to think about what are the levers of product, like mass, resiliency, stiffness, and geometry, that we might want to play with. And when we play with those, could we make a change to the shoes? You know, for example, every 100 grams that you add to a shoe makes you less efficient. So how do we work on that? We really thought about those from the product lever standpoint. We thought about human factors, and we also thought about the athlete, training, nutrition, economy, efficiency. This then led to, wait, we probably need someone who can break it. So how do we identify athletes that would be capable? And so we did identify 3 athletes working with our academic partners. We thought about their skill level and the speeds they would be going, and then we started to think about how we could change those levers in product. We did aerodynamics, we thought about their clothing and apparel, all of that put together, and then that race optimization. And we added it all up to really try and think about how we could break this 2-hour marathon time. And we did it in Monza, and we just missed it. He ran 2 hours and 85 seconds, so just missed the mark. But then came back in 2019, 2 years later, and actually in Vienna managed to break this big milestone, which was fantastic. And we kept working with him throughout that and kept building those new products and new design guidelines. We also thought about how he was dressed and whether we could change that face of the design of the marathon runner. And Elliot will probably never go back to shorts. He really likes his half tights. So there's just some really great learnings that we had in that. But what if we'd applied it to women? What would that look like? Well, so in terms of going through that, what I want to go, from this example, I'm now going to go through some other examples that we've applied to women. And I want to do it from 4 standpoints. The first is, if we thought about that question of fatigue, that's the research. Where do we learn about the athlete, the problem? What are we trying to solve? What is our why statement? Then clearly we work with our teams. So what are the inputs into product design that might lead to a change? Then we come back and we test those products. And then at the end, we're trying to service the athlete. So I'll try and work through each one of these examples through this 4-point, very simple plan, seemingly. But you may have seen recently, we did do a project and we called it Project Dreamweaver. And in Project Dreamweaver, we took 120 athletes who were trying to make the qualifying time, the Olympic qualifying time for the marathon. And everything we did with fatigue, we now sat down and said, well, what if we built a community? And what would that look like? And so the same thing, we did in-field, we did in-lab research, we thought about it from a running, we thought about product levers, everything we could learn about these athletes. You can see that down the bottom, we added things like resilience, connection, we added in psychology, we thought about menstrual cycle, are you having babies, all of these things and how we could best support these female athletes. We thought about their apparel. Whilst this was predominantly around the footwear, we also really wanted to talk to them and get insights about how we could improve their apparel and what they need in their apparel situation. And then they went to the Olympic trials. It also turned out that when we were building our new AlphaFly 3 that has just been released, that we had a group of athletes, and it was the largest group of athletes that we've ever had that we could study all the way through to help build these shoes better for women, and they were testing them the whole way through. So they did both the product design and testing for us to really make sure this shoe was right for them. At the end of the program, it was really successful. We had more than 50% have a new personal best. 15 of them achieved the Olympic qualifying time, and we had a lot of product insights. And as you can see from this picture, we were working with these athletes for 2 years. We had women going through pregnancy, having babies, being mums. Some of them are doing PhDs, pursuing medical degrees. So they were coming from a really broad background. And so trying to work out how we could build this community of women around the US was fantastic for us. It really stress tests some of the work that we were doing and how we could build better product for them. But what if you're maybe like me and you really, really want to run, maybe, but you find it a bit hard. Like, I really want to run, but I find it a bit hard. So what would be available for someone like me? Like, am I wearing the AlphaFly 3? Is that right for me? And actually, with this athlete, we went, well, how much do we know about this everyday runner? We have Nike Run Club, we get data coming through all the time, what is the average speed and pace? And then we sat down and said, well, if we actually get someone and put a sensor on them, how do they run? And so what you can see is when we get started, we go out really fast, heart rate goes up, and then it's like, I have to sort of stop, and I start walking. And so if I just looked at average pace, now all of a sudden I'm missing the fact that I'm going fast and running, and now I'm walking. So my average pace isn't reflective of maybe what I'm doing. And so what is the minutes of mile that this runner is doing? You can see there's spaces of walking, there's spaces of jogging, and so this was a new behavior for us. And so what was really interesting when we had to think about this individual is to think about it from, hey, what do we have to do also for behavior change? What is going to make her go out to do a jog? So I need to get her product that feels good, that looks exciting, that she wants to put on, and she's in that contemplation phase of, I want to go out and run. Then in the movement, I have to think about what do we need to try and provide to that athlete, and then post-jog, she has to finish and go, yeah, I'm ready, I can try it again, right? So we're trying to think of that whole design process. So we thought about what are the things that make running hard? Well, sometimes when you crash into the ground, it might hurt. So how do we make it a bit softer? So we thought about ground reaction forces and thinking about lowering that rate of force increase and having softer cushioning, a softer ride. Right? How could we do that? And then we thought about, is there something that we could do that would give us a better transition so it's easier rollover? And so we had a flatter foot angular velocity from initial contact to mid-stance, a smoother transition. And then we tried to think about moments where we could reduce eccentric joint work, so it might be easier for her and easier for her to take off. And so we designed a shoe called the Motiva that really allowed us, with those, just thinking about those simple levers, we could work with our amazing makers and think about it from a, what is the stack height, what is the geometry, what is the type of foam. Okay, all of those things coming together to build a product that would allow it to maybe be nicer, less crash, easier to push off. The other thing when we did athlete testing is that we were hearing a lot from our athletes that the shoe was a bit too narrow at the front. So we really wanted to reduce that forefoot tightness. And so in the end for this, we built a shoe that actually had a soft heel for the crash. We had bump geometry on the bottom of the shoe, if you've seen Motiva. So that was a way that we could also help with the transition and the softer cushioning. We had a smooth rocker geometry. We tuned our heel and toe offset. We had soft and resilient foams. And then we also changed the forefoot wideness. So we changed the shoe so it was more comfortable for her. And so then it makes running happy. Like, she's happier running, and we go out and she wants to run again. And so that shoe was really trying to say, here we've got a pinnacle of performance, and over here we've got someone who wants to, and is there a difference or a separation in how we need to design for these two athletes to move them into their next stage of the journey and maximize their potential. Now, as many women would tell you, we have this quote quite a lot, that I can exercise without my sneakers, but maybe not without my sports bra. So we've focused a lot on shoes, but then as we open that aperture and really think about our female athlete, what are they having to wear when they run? And is it inclusive? And is this going to be an area that will stop them from actually participating? So what's interesting, and this work is from quite a while ago, but a lab in the UK found that the top barriers for exercise for women was really energy, makes sense, time makes sense, health makes sense, but the number 4 one was breasts. And so when you start thinking through what is something impacting, we're doing behaviour change, we're doing all of these things, but if we can't get you into the right bra, then there's probably no sport. So it could be that simple. So let's go into and see what we can learn as we think fatigue, community, what are the information that we need to learn in this journey. So when I think about bras, there's a lot of work that goes into the wrong type of support, meaning something that's painful, it's compressing, it makes you feel uncomfortable, you don't feel like you can hit the weld. And so how do we move you through into getting support that's going to be right for you, that can have a performance advantage as well as just make you feel good? If we think about the athlete research behind this, the breast itself has very limited anatomical structures that help support the soft tissue. And it's interesting going from footwear, the foot is more rigid, biomechanics, we assume there's no soft tissue, we try and get rid of all of that difficult stuff, and so now we're saying, hey, let's bring it in, let's just go full on into soft tissue and see what we can learn. And it turns out like there's 3 major tissue types in the breast, and they all are working together for a purpose that isn't probably activity. If we think about this from a different point of view, someone's breasts could be more fatty, have more fatty tissue, and someone could be more glandular. And actually the work then shows that if you have a breast that might be more glandular, it could be more dense. And if I have a more dense breast, then that could change things. But one might be more or less compressive than another. And actually, if we think about the equation of mass equals density times volume, thinking about whether the breast is more fatty or less dense versus more dense affects the mass, and therefore might affect how I'm interacting with that bra and that product. And just to show you an example here, this is two participants, one who had heavy breast tissue, one who had light breast tissue, and then you can see a medium and a high support bra. And so when we put them into different products, simply based on the tissue, we had a very different experience. Sometimes, if you had light tissue, it actually didn't matter what type of bra I put you in, you were supported, you loved it, it was fantastic. When the tissue type changed, it really affected which bra I put you in and whether you could be active. Makes sense, but it's good to think through. Then you think through, again, what stage of life are they at? So what could be their age? Are they at a different stage of their cycle? Is that affecting does the breast tissue grow during different stages of your cycle? And are they going through pregnancy? Are they postpartum? And what changes in body shape could they have? Female athletes are very exciting because we continually change through our whole life. So exciting, but how many women actually go and refit for bras or refit for shoes or refit across that journey? So let's embrace our change. In thinking through the product design, then we have to start thinking about body shape and fit. So what is the volume of the breast tissue? What is the mass of it? What is the girth of the torso? Is there asymmetry? What is the different breast shape? Some people have come up with like 12 different breast shapes or more. So what is the shape of the breast tissue? What is the total tissue? I put this because when we have tried to expand our research into athletes of larger bodies, the breast volume itself might not change, but other adipose tissue surrounding the breast might be included into the bra. So it could change how much volume needs to be put or encapsulated into that product. The body shape. Am I a swimmer with a wider shoulder? Do I have bigger trapezius muscles? All of these things. Do I have shoulder injuries? What's going on in that? And how do I include that? And then my preference. All of you, even though they will realize that, do you like clothes that are baggier or looser? Do you want something to be more compressed or tighter? How does that make you feel? And so taking all of that into consideration when we're thinking about body shape and fit. And then when you think about the diversity of body shapes and how you're going to fit all of them, they may all be a size 8 foot, but you can see that the diversity of body shape is quite extreme. The other thing that we know is that as soon as she puts on a bra, we have the advantage because yes, she can now be active, but it's a straight disadvantage because the bra is more insulating. And so it affects how much loss of the heat how much heat we can lose. It makes us retain sweat, and then we can be have thermal discomfort. So we know that there's an advantage to put it on, and there could also be a disadvantage to that. When we think about product design, we're also thinking about movement. And so we have typically used vertical breast displacement as a key indicator to discriminate between different bras and whether someone is feeling good in that bra. This is really highly correlated to how much support someone feels, and it's a standard protocol. And so that allows us to start generating and thinking about what substrates or how we can build accordingly. What's interesting is, again, when we think about how different she is in different body types, on this graph, on the vertical axis, I have support liking. So do I like it? Is that high, then I like the support, or low? And then across the horizontal, I have bra support. So is that bra more supportive for an individual or less supportive? And so if I look at size small women with less breast tissue, you can see that it doesn't matter whether it's providing the support as we measure. They like all of them. Everything's good in their world. They love it. They're really after different designs, and they're probably really thinking more about comfort. And so if I think about our Dreamweaver running population, what is the comfort that she has? Is thermal discomfort probably more of a need in that athlete? If I think about our size large individual, you can start seeing now we have discrimination. So then based on whether that support is being offered to her in the right way, then she will like the support offered to her. But she doesn't care about the brand. She's very much on, is this bra working for me? And then when we got to our women in larger bodies, and I like to call this out because we only could find 4 bras for us to assess. We didn't have enough. So one of the steps we've also made at Nike is to be more inclusive and release product across the full size run so that every athlete has access. But you can see in this athlete, this one was really more thinking probably about the comfort first before they got into any other functional needs. And if we think about the hierarchy of needs for these athletes, whether you can get something that fits is probably the first thing, then you go into function, then you go into feel and aesthetics, and at the end of the day, you just really want it to feel like it's not there, right? So it's interesting when we start thinking about the dynamics and the needs of different athletes across the population. And the other thing here is when we think about the torso motion, every time you put on a different bra, you change how you move. And so when we think about female athletes, and all of us who only think about the lower body, that we're having athletes move, every time we change what we put on them at the upper body, it could affect how they move, how much their torso is going up and down, how much rotation is going on. So I just encourage everyone to think a little bit more holistically as we go through here, because again, we've got 50% of our mass in our upper body. And even when we're trying to compare bra to bra, because she's already changed how she's running, we're only looking at vertical breast displacement. Is that the right thing? So what are the other methods that we could use to assess there? And what is the effect on performance? The other thing that we've found quite a lot, like we've looked at vertical breast displacement, but the initial breast position could be important, the amount of compression, so thinking about the moment arm of that breast tissue, and then timing. Does the timing of when the tissue reaches its bottom really coincide with when the torso reaches the bottom of its run, or are they out of whack, I say, but a little bit asynchronous? And so which variables are the most important for an athlete? And so this gives you more of a spectrum to consider when you're thinking about those products. The big thing then is she didn't just run. Crazy, I know, but women do more activities than run, and so sometimes when you're running, that's a very repetitive motion, but now when I start doing other movements, this support may or may not be appropriate. The other thing that might be interesting to note is she also uses her arms. And so when we use our arms, if we lock our arms to our side, we can reduce breast motion by about 11%. If we're doing volleyball blocks, we might increase just the breast motion with our arms up by 16%. And if we're doing like a tennis swing, then breast motion could also increase by 35%, right? So really thinking about what is that full athlete doing holistically and how that might impact what's going on when we're assessing their motion and building product for them. But ultimately, what we try and do is put all of this information together. Information on how she's built, size and fit, where she sweats, where the sweat pools, where she gets hot and cold. And then build that with our maker partners digitally to try and build the product on body. And then provide some of that motion and functional biomechanics data to think about the product and how it might move and cope or help her in her motion. And so ultimately then for bras, we're really thinking about this structure of support means filling my boobs, but comfort means not filling my bra. So I can be very specific on the function I'm trying to generate, but if we don't have that sensation and emotional connection, it's probably not going to work for her. Okay. Ooh, black screen, interesting. So what is Nike is now really trying to think about doing is providing options. So if we think about some of our 3 families of bras, a late, indie and swoosh, we are now allowing our athletes to come in and decide what sort of look do they want? What are the attributes they're after? What is the support level they're looking for? How do they need their closures? And then try and find them the right product from there. So thinking through then, we've built this product all the way through to the experience, how would we sell this product or how do we get her into the right product to be her best athlete, is an important part of the story. Right, so back to our Dreamweavers. You've heard about that bras can be insulating, and we've talked about a few aspects here. But if you think when you go out for a run or you go outside, how many of you probably start like the photo on the left? And then how many of you might end like the photo on the right? What happens to all those clothes? Right? You may have seen that the clothes get discarded at marathons all the time. And so that was another challenge that we really wanted to try and face. And some of you might be aware of, you sit inside. If we think about the green line, you sit inside and you're at rest, and then I'm like, oh, I'm going to go and be active. And so now I go outside and I start doing some light activity, but it's probably still warm, or I go outside and it's, cold, and all of a sudden I'm really cold, so I'm laid up. And now I start being active and my metabolic rate goes up and I start getting hot and my skin temperature increases. All of these things change. And so then if you think the insulation indoors that I need is probably less, but as soon as I go outdoors, I've got this need to stay warm. And then all of a sudden, as I start getting hotter, I need to shed layers, right? So we're working on this sort of premise. As I said, we start getting hot, our metabolic rate goes up, our skin and core temperatures raise, we start sweating, and then we have moisture in our garments. So when we think about our female athlete and our male athlete, we think about where do they get hot, where do they sweat? And then over on the right, you can see in this little graphic exactly what we were talking about, that I sweat. That sweat gets pulled in my bra or my shirt. If the sweat can't evaporate, I'm not going to get cool. So how am I trying to move that sweat through the layers so I can be cool? Right, so this is where we were talking about how the sweat can't move through, but we know where she sweats. And the team has done multiple studies to think about how skin temperature, moisture, all of these things change, the time at which they change, and whether something could be important for us to help cool. And so if we think about product design, and sorry, I've gone to a PowerPoint version, we know that we can be building vents and holes to help cool the body and improve breathability of garments. And in terms of athlete testing, one thing I didn't probably talk about when we were thinking about bras, we did build a soft tissue robot to try and think about how we could look at the support of bras on a 6 degree of freedom platform, and that helps us iterate quickly. And we do the same thing in our thermal and environmental chambers, where we have two, we call them sweaty mannequins. Hal is on the right and Haley is on the left. And when we first started a lot of this work, we didn't have a female mannequin, and we used to just put a chest plate onto the male mannequin and call her Helena. And through that journey, we found things, and we thought we were doing a great job for the female athlete. But then we really made that investment into building that female mannequin, and getting that female mannequin found that when we built things for him, it didn't work for her. And so we started to find this separation in gender, which was really exciting. And the team has done lots of lots of studies to make sure that the insulation need of a runner or an athlete is mimicked by what we can get from our mannequin thermal resistance values. And so this really led to, hey, could we come up with a concept that might actually adapt? We know how the body heats up, we know when it starts to sweat, we know how much sweat might evolve, and we came up with the thought of something like origami. And this is a jacket that autonomously adapts to the body based on one trigger. And the trigger, it turned out, was the amount of sweat. So that seemed to be the best trigger that we could use to start having this jacket change. And so you get hot with the sweat, we then put in some fancy layers that were moisture reactive. They reacted to the sweat. So as I'm running, I get hot, I start to sweat. With the sweat, you can see the jacket, maybe we needed to turn those lights down, but you can see the jacket start to change. And the jacket changes, vents open up, you get cooler, and your body temperature is more regulated. So now we have this jacket that's thinking about how much you're sweating, changing on the fly, and when the sweat goes away, the vents close again. I don't know if everyone could see that. As we said, that we know where she sweats, we know where he sweats, we know where they need to get hot and cold. And in this situation, the vent placement specifically for our female athlete had to be different. And so we do have women-specific jackets compared to men. And we have more vents across the area where the bra would be. Really thinking about how can we help cool that female athlete. And that allows her to run in the same jacket and not have to take it on and off and navigate all of that. Oh, sorry, let me just move to the next bit. So at the start, I think I said that Nike is really in the process of maximizing potential. And I think really we have a think tank of elite athletes at Nike, and they really also said that you can't maximize potential if we don't maximize opportunity. So what I've really tried to do today is see how we could open the aperture, think about our female athlete, think about it from big problems and taking lots of data to come up with product solutions that allow her to be active and allow her to be active in the way that she would like to be. So thank you. And sorry about the slide hopping.
So we have time for a few questions. Please get up and come side and ask the question. And Bridget is going to repeat the question for the audience online so that everybody hears the question. Questions?
No question. Yeah.
Thank you for the wonderful talk. I wonder what advice you might have for some of the early stage students or investigators and audience here that see themselves in pursuing their footsteps in careers with science, mathematics, biomechanics, or psychology. Yes, I'd be interested in that.
Yeah, thank you. So the question was really about what advice we might have for people who are interested in a career path that's similar in this area. And to me, I think part of it is to make sure you don't stay in your own area of expertise and hole, and really come out and try and get some diverse thought, talk to others, and think about how your problem from multiple standpoints. There you go. Problem from multiple standpoints and get different points of view that can help you solve differently. I think on that journey you'll open yourself up to learning more about different areas, and then you'll be able to navigate one that seems of interest to you. But that real problem solving spirit, thinking about the problem first and then how it's going to solve, rather than just going to, here's something really cool, look, I've got to solve for something that may not exist. So really thinking, talking and understanding what you're trying to achieve. Yep.
I guess I want to stand up because I'm on the
Yeah.
So what got Nike to realize that it was necessary to have to look at women as not just scaled men?
Mm-hmm.
Was it profit? What was it?
It's a great question. So the question is really saying, hey, has Nike really considered women throughout our journey? And Nike has considered women throughout the journey. Just recently, I think we've doubled down that investment. So in trying to double down that investment, we're really thinking about her throughout that journey and thinking about involving her in more steps of that journey. And our female athletes have also really tried to come more to the party and say, hey, can you think about us as a unique unit? So in the past, maybe we haven't had as much involvement from female athletes, and now we do, which is exciting. And again, we are trying to really raise that potential and think about how we can build specifically from her standpoint first and foremost. I don't think that there's been a change in terms of at the lab level. We've always been engaged and interested in female athletes. I think as a company, we've focused predominantly on a few sports, and we've opened up that aperture, and I think that's where more of that research can come through to product and stories. Yeah. Yes, Jeff.
Is the time coming where everybody will be able to get custom fit clothing that expand your body and you get kind of tailored athletic wear? Is that something that's possible or coming?
I think that is definitely possible. I can't say whether it's coming, but bespoke product is always possible. It's just whether I guess it's needed would be the first question. And if we all do our jobs properly, maybe you're involved and concentrated in the wider group. But yeah, I think anything's possible. And I guess that's the exciting thing for me. A lot of things are possible, and then you get to that stage of when is the technology ready to maybe deliver some of those solutions, and then when is our athlete ready, and is that athlete, like, is that solution going to solve a big problem for the athlete? Yep. 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 Yeah, so the question was, if you're not working out, are these products still maybe applicable for you? And to me, the answer comes into, we're looking then at time. So is it the time that I'm engaging in a run, or is it the time or the cumulative time that I'm sitting in a room? And so making sure that when we're doing our athlete testing and getting those insights, we're really thinking about it from that standpoint. If I build a shoe or a bra or a shirt, and I get someone to wear it for 5 minutes, then that's not helping someone who's going to wear it for a marathon either. So we really need to think about the specificity of what we're building for and make sure we design and assess accordingly. Next question. Jacqueline?
Hi. You showed us some fantastic research that you're doing in marathon runners, and I'm curious what research you're doing in different terrains, like trail, either marathon or ultra marathon.
Mm-hmm. But we do have trail shoes on the market. So we think about, if we think about running, we would be thinking about running from a performance, from a participation. We might be thinking about it through different lenses. In the lab, we have running track and we have concrete surfaces. And I don't know if anyone saw, but we also have a ramp outside at a grade and an incline. So we are looking at trail athletes as well in that. So really trying to dimensionalize what running means and make sure we're looking at the right things to build the product for them. Yeah. Yeah.
I was trying to say, so as like a biomechanist, you started like rehabilitation work, and that's how you kind of got started, and you answered the question saying that you didn't kind of like limit yourself in the box, kind of like expanded out.
Yeah.
Do you see any potential collaboration or even just future work that might be could do for post-injury? Because I know it's a lot of like preventative services, but
yeah, I think that's a great question. So the question was really, is Nike interested in rehabilitation? Nike's interested in participation. So we want you to be active and stay healthy. If you're going to participate in activity, you're going to take on risk. By taking on risk, you've got a risk of having an injury. So everything we are doing, we're thinking about how we can improve performance as well as reduce or lessen the risk. And then at what stage, how do we meet you where you're at to give you what you need to improve? And I think you raised also my background. And another learning maybe to our first question is my first study was looking at spring-loaded ejector chairs for older people to get up to be active. So if they didn't get up and walk, then they were stuck in a chair all day. So that wasn't good for their health. So it was great because I was trying to design and think about how someone got out of a chair. And then through that journey, I went, I want to do athletic footwear. And my supervisor gave me a great piece of advice of, that's great, but there's a lot of people doing athletic footwear. What could you do that would make you a little bit more distinctive? You could still learn all about it. And that's where I moved into, I'm going to do footwear design, but I'm going to do it for a clinical population of rheumatoid arthritic people and try and reduce falls. So I still learned all about athletic footwear, but I was applying it to a different situation and a different population. And so when I went to the footwear conferences, I was sort of a little bit out there. So it was it was great because it provoked a lot of thought and discussion. So Nike is very interested in everyone being active. And so from the lab, we're always doing research in those sorts of fields. Yeah, definitely. And you may have seen the, was it Back to Future shoes, and we had self-lacing shoes and things like that we've put onto the market. There's always interest in wearables, there's interest in device and the type of data that we might get, and then the fidelity of the data and what it's going to answer for us. And again, if I come back to that, what is the problem we're trying to solve? That's where it probably really becomes our issue. So are we trying to solve and build something that's going to track or change or adapt, and what is that solution path looking like? So really thinking about it from that standpoint might mean we might dabble, we might innovate, but we may not commercialize. Yeah. And to that point, we may build tools that we use in the lab for research without necessarily commercializing.
All right, thank you all for coming again. I want to thank, one more time, thank our speaker, Dr. Bridget Munro. I want to thank the Zorowski family for their support for this lecture series. And I also want to thank a few people who helped us make this event possible. Jessica Sarath, my assistant in the front office, did a lot of the work. And Jack, who's running around right there in the back. And Jack, of course, made sure that we had a relatively smooth operation today. So thank you, Jack. And again, thank you all for coming, and see you all at the next year's Zorowski lecture. So we'll be having another good one. Thank you. Oh, just a quick, we do want to present Bridget with a memory.
Oh, thank you. Fantastic. Thank